The primary purpose of the next example is to introduce the concept called overloaded constructors. And basically an overloaded constructor is going to allow you to provide multiple different ways for the client code that's using your class to initialize objects of your class. Now, in addition to demonstrating and introducing that concept in this example, we're also going to take a look at a more robust version of the time class that we introduced earlier. And in this version of the class, we're going to make it a lot more flexible. We're going to add in some properties for manipulating the hour, minute, and second instance variables. You'll see that we're going to individually be able to validate the hour, the minute, and the second. We will, like I said, demonstrate the concept of overloaded constructors, which you can see here at lines 12 through 19. We're also going to introduce another use of this keyword as well, something called a constructor initializer, which allows you to use this keyword to call one constructor from another constructor of the same class. So we have a number of different concepts to look at here. And in fact, you know what, let's take a look at the time2test class first to show you how we're going to use this new time2 class. Then we'll go back and look at the actual definition of class time2 as well. So as you can see here in main, we have at lines 9 through 13 declarations and initializations of 5 time2 variables, T1 through T5. We've also declared T6, which we'll use a little bit later in the program. And at lines 9 through 13, you can see that we're creating new time2 objects, and in each case, we're passing different arguments to the constructor. In the first case, we're calling the constructor with no arguments, and as it did in the first example, that's going to result in a time that's set to all zeros for the hour, minute, and second. We have a version that's passing just a single integer into the constructor as a parameter, and that's going to result in setting the hour to 2, and the minute and second will still be set to 0. This version that's receiving 2 arguments is going to specify those for the hour and minute respectively, and then 0 will be the default value for the second. The version with 3 arguments here will set the time to those 3 values. And then finally, we have a time2 constructor that once again takes a single argument, but the type of that argument is an object of class time2. It's the T4 object, and basically what we're saying here is that we'd like to initialize this new time2 object that we're calling T5 with a copy of the contents of the object called T4. And to demonstrate that all of these objects were initialized appropriately, and we've put comments after each one to show you how they're being initialized, for each individual one, we're going to tell you how we constructed the object, and then we're going to show it to you in both the universal string format by calling toUniversalString on that object, and the 12-hour clock format by calling the toString method on the time2 object. So let me go ahead and run the program so that we can see the output from the part of the code that's currently displayed on the screen for the objects T1 through T5. And when I run that, we can look back at the initializer values in main here. So here's our output, and here are the initializer values. And we can see that T1 came out with all zeros for the 24-hour clock format and midnight for the 12-hour clock format. For the second one, where we had just the argument 2, that became the hour, and we got zeros for the minute and second. For the third one with 21 and 34, those became the hour and minute, and we got zeros for the second. And of course, when we do 12-hour clock format, the 21 becomes 9 p.m. in that case. And then 12, 25, and 42 became the 3 values for the hour, minute, and second for the time object T4. And finally, when we copied the contents of T4 into the new time object that we're calling T5, we once again see the same values for that object. Now, the other thing that we're doing in main in this example is once again demonstrating the concept of an argument out of range exception. And you may recall from the original time1 example at the beginning of this lesson that there was no way, based on the way we wrote the setTime method definition, to figure out which of the three parameters, the hour, the minute, or the second, or any of them, were the invalid values. Now, as you can see here, line 42, we have an object called T6, which we're initializing as a new time2 object, and we're giving it three invalid values for the hour, minute, and second, respectively. And we're going to see that an exception occurs. We're going to catch that exception, and we're going to display the exception's message to show you what went wrong. And if I stop there and go back to the output and scroll down a little bit here, you can see there was an exception while initializing T6. We printed that here. And then it says hour must be 0 to 23. So we know that the hour specifically was what caused this exception to come up. Parameter name was hour. The actual value was 27. And that, of course, is out of range. It never actually got a chance to evaluate the 74 or the 99 because upon trying to initialize the hour, an exception occurred right away. So now that we see how we're using class time2, let's go back and take a look at the actual definition. Once again, for our class time2, we've declared three private integers, hour, minute, and second, and we're declaring them private because we want to encapsulate them within the objects of class time2. We want to hide them within the objects of class time2, and the only operations that we want to allow to be performed on hour, minute, and second are defined by the public interface of this class. The time2 constructor that takes three integers, the time2 constructor that takes another time2, the set time method that allows me to set the time to the specified hour, minute, and second values, and then the hour, minute, and second properties, and finally the toUniversalString and toString public methods. All of those members of the class are declared as public so that client code that's using class time2, in our case the time2 test class, is able to manipulate time2 objects using those constructors, methods, and properties. So now let's go ahead and take a look at the time2 constructor defined at line 12 through 15, lines 12 through 15. You can see here that the time2 constructor receives three arguments, and recall that you can specify default values for arguments to a method. In this case, we're using equals 0 for each of the three parameters, and what that means is that this constructor can actually be called four different ways. It can be called with no arguments, in which case 0, 0, and 0 will be passed automatically by the compiler to initialize hour, minute, and second to 0. It can be called with one argument, in which case that will become the hour value, and the minute will be 0 and the second will be 0. It can be called with two arguments representing the hour and minute, and then the second will be 0. Or it can be called with three arguments in which the explicit values we specify are going to be passed into the constructor. And just to reiterate, that's what we were demonstrating here in these first four time2 objects that we were creating in lines 9 through 12 of main. So this using default arguments in a constructor makes the constructor more flexible and allows you to call that constructor multiple different ways. Remember, by the way, when you're using default arguments like you see here, that if one parameter has a default argument, then all subsequent parameters in the parameter list must also have default arguments. Now, as you can see here, our time2 constructor, rather than duplicating the work of some other methods in the class, is just going to call setTime to actually perform the setting of the time. And we'll take a look at the setTime definition momentarily, but setTime will be responsible for attempting to set the hour, the minute, and the second. Now at line 18 we have a new feature that we're demonstrating, the so-called constructor initializer. It is commonly the case that one constructor does the work that another constructor needs to do, and the reason that you have overloaded constructors is basically to provide different ways for initializing objects of a class. So it's to provide flexibility to the users of your class to allow them to initialize objects different ways. And it's very common throughout the .NET framework to have lots of different constructors in a given class that provide that flexibility. So here at line 18 we have another public constructor that allows a new time2 object to be initialized with a copy of the contents of another time2 object that's passed in as an argument. Now, rather than duplicating the code of the body of the time2 constructor at line 12, we're going to use a constructor initializer to call the time2 constructor at line 12. This, with a set of parentheses following it after a colon, is a call to the other constructor, in this case the one that takes 3 integer arguments, and if I hover over it you can see that it's telling me I'm calling the time2 constructor that takes an integer, an integer, and an integer. And the syntax for doing that is to follow the parameter list with a colon, the this keyword, and a set of parentheses containing the arguments of the constructor that you'd like to call. Now notice how we're accessing the hour, minute, and second of the other time object, the other time2 object I should say. We're using the properties called hour, minute, and second, which we're going to look at the definitions of momentarily, to get the hour, get the minute, and get the second out of that time object and use them as arguments to the other constructor. So when the time2 constructor gets called with another time2 object, we'll extract its values, pass them to the constructor at line 12, it will in turn pass them to setTime, and setTime will perform the actual setting of the hour, minute, and second. Let's take a look at our new implementation of setTime. You may recall from the first example that setTime had all of the validation built into a large condition in an if statement, and only if the entire condition was true would we set the hour, minute, and second, and then if it was not true we would throw an exception. In this case, setTime is simply using our new properties that we're about to look at to assign the hour property the value of the hour, the minute property the value of the minute, and the second property the value of the second that's passed into the setTime method. And for each of these, we're going to individually use them to validate the hour, minute, and second. So setTime is actually calling the set accessors of these 3 properties to do the setting of the individual values. So for example, let's take a look at the hour property. Here we have a get accessor that simply returns the hour, and we have a set accessor that validates the value that's being assigned to the hour data member to make sure that it's greater than or equal to 0 and less than 24. Remember that this special keyword called value is used in a set accessor to represent the right side of an assignment to a property member. So H is going to be stored in the value keyword, and so I'm taking whatever H's value is when setTime calls the hour property. It's checking to make sure that value is greater than 0 and less than 24, and if it is, we assign that value to the hour. Otherwise, we throw a new argument out of range exception in which we are supplying several arguments to the constructor. You can see in the tooltip that appears here when I hover over the constructor name that it expects a string parameter name, an object actual value, and a string message. So what's happening here is it's taking these 3 items and it's assembling them together into the actual error message that's being displayed. So the error message string hour must be 0 to 23 was part of the ex.message that was displayed from main. The parameter name was hour, and the actual value was specified here, 27. So this is a format that's done for me automatically as a result of initializing the argument out of range exception with these 3 argument values. So as you can see, the property is going to validate the data, and if it's invalid, throw an exception. So what happens, going back to main for a second here, when I say to create the new time object T2 and pass it the hour value of 2, that's going to call the time2 constructor, and if I right click on that, I can say go to definition to jump right to the definition of the constructor. The hour is going to be receiving the value 2 for the parameter h. That's going to pass into setTime. SetTime is going to assign that value to the hour property. The hour property is going to validate that value and assign it to the hour, and if it was invalid, the hour property would then immediately throw an exception. If that exception occurs when SetTime is evaluating line 25, then lines 26 and 7 will never execute, and back in main, for example, in the case of the T6 object, we had an example like that. Here we had an invalid hour, and once this time constructor fails, the exception that was thrown will be caught here at line 44, and then we will display the exception message. And again, these 3 lines of output are all being produced by displaying the result of the message property for that exception object. So for each of the properties that we're defining in this example, we are validating the value and throwing an exception if it's invalid. And you see for the minute, we're checking to see if the value is greater than or equal to 0 and less than 60. Otherwise, we throw an exception customized with strings about the minute parameter, and then finally, or the minute member. And then finally, for the second, we check again to see if it's greater than or equal to 0, and less than 60, and otherwise we throw an appropriate exception. And then finally, down in the 2 universal string and 2-string methods, you'll notice we're using the properties to access the hour, minute, and second to get the universal string format, and again down here to get the 12-hour clock format as well. So there's actually a good practice when designing a class that says minimize the total number of locations within your class's code where you directly modify the instance variables of the class. So if we take a moment to look through our source code here, of course we declare these 3 instance variables in lines 7 through 9, but as you look at the first time constructor, it never explicitly refers to hour, minute, and second. If you look at the second time to constructor, it never explicitly refers to the instance variables. It does refer to properties, hour, minute, and second. The setTime method does not explicitly refer to the instance variables. It uses properties. The hour property does explicitly use the hour instance variable, and that's because it has to be able to go get the value of the hour, and it has to be able to set the value of the hour. So that is directly accessing the hour member. Similarly, the minute property is accessing the minute member, and the second property is accessing the second member. The other methods are not explicitly accessing the instance variables. And what does that mean to us in the context of this concept called encapsulation and data hiding? Even within your own class, you should always access your own data members, your instance variables, as often as possible through the methods and properties of the class. And what that does is it protects you against future code changes and makes your code easier to modify, maintain, and debug. If something goes wrong when we're setting the hour and somehow a bad value gets placed into the hour, if the only place in this class that ever modifies the hour instance variable is this hour property, that means we can focus our debugging efforts on this property and see what we did wrong. So for example, let's say we accidentally put a greater than sign here, which would only allow us to set the hour to 1 through 23, not 0 through 23. That would be a logic error in our hour property. And if I then provided an hour value of 0 and it threw an exception, I would know that the problem has to be in this hour property that we've defined. And similarly for the minute and second. Also, if I ever get the hour, the minute, or the second, and it comes back to me as an invalid value, because the only thing that ever manipulates the piece of data directly is the corresponding property, I would once again be able to focus my debugging efforts on the 3 properties called hour, minute, and second, respectively. How about modifiability? If you look at the way that we've represented the time, we have 3 separate integers representing the hour, minute, and second, respectively. That typically is going to require 12 bytes of memory to store that information. Well, it turns out we could also represent the time of day with a single integer if we assemble the time into the total number of seconds within the day. So if we had made such a change, now what kind of code changes would we need to make throughout this class? Well, the first constructor, if we still want the user of the class to be able to supply hour, minute, and second values to the constructor, this constructor would not need to change because it's not immediately accessing the instance variables. It's simply calling set time. And this constructor also would not need to change because it's not accessing hour, minute, and second. It's calling the other constructor. Set time wouldn't need to change because it's not accessing the hour, minute, and second instance variables. It's using the properties that allow you to manipulate them. And if I scroll all the way down to the bottom here, the two universal string and toString methods would not need to change because they too are not directly accessing the hour, the minute, and the second. If we wanted to represent the time as just the total number of seconds in the day, which is a good exercise for you to try to modify this class in that manner, all we would need to change are the hour, minute, and second properties. So for example, to get the hour, if we store the time as the total number of seconds in the day, the get accessor would have to perform some sort of calculation to figure out, based on the total number of seconds in the day, what hour it is. And similarly, the get accessor for the minute would have to figure it out from the total number of seconds in the day, based on that value, what is the current minute, and similarly for the second property, what's the current second. Also, for setting the hour, we would have to first break down the total number of seconds into the day into its hour, minute, and second components within this set accessor. Then we would have to change the hour value and reassemble the hour, minute, and second into the total number of seconds in the day to set that instance variable's value. And we'd have to do similar operations inside the set accessor for the minute and inside the set accessor for the second as well. So even when you're defining a class, you want to minimize within the context of your class the total number of touches, if you will, of the instance variables that are defined within that class. And by doing so, you will make your code much easier to maintain, modify, and debug in the future.